let's test our work on the Unitek Servo drive. Now, I don't have the motor, but that mates to this drive, but I have another motor from a knitting machine that has a resolver in the back of it. We won't be able to run that motor, but we'll rotate that resolver and see the output of UV and W fire. Here's the motor with the resolver that we're going to use. You don't need no gym membership around here, do you? All right. Put this. Homemade resolver cable. We're going to connect to the resolver of the IRT motor. Okay. Excitation A, B, C, D. A, B, C, D, E, F. Here's cosine, A, B, C, D, E. Six dots. Here's sine. B, A, B, 3 dots is A. Okay. These two wires are for motor thermal. We're not going to hook those up. Okay, there's our resolver connections. Now for the scary part, we're going to connect our voltage doubler variac to the DC bus input. I don't have this connector right here, so we're going to have to clip onto it. Ground right there. Okay, I'm going to power up the variac and voltage doubler. Right there we have 291.4 volts DC. You see our LEDs have turned on. I've got a mirror looking at the front of the drive there. We're going to take it up to 500 volts DC, slowly. 325, 369, 370, 414, 430 volts DC, 459 volts DC, 484 volts DC, 500, 520 volts, 521.1 volts DC. We're going to stop right there. We could take it up to 565 volts DC, but I'm a little bit nervous. Especially clipping onto that Euro connector with high voltage. So we'll stop right there. Let's see, it's gone up 522.5 volts DC. All right, let's stop right there. Next, we're going to hook the scope to UV and W. I'll rotate that IRT motor's resolver and we'll look at the waveforms at the output when we enable that drive. Okay, there's U. Don't short them together, Peepaw. U. And V. Okay, let's hook up our enable. This is our enable switch. All right. Let's power up the drive. .4 volts DC. Let's enable the drive. Rotating the IRT motor's resolver. U to V looks good. Let's bring the time back in a little bit. Okay. I'm going to power down. Let's disable the drive. And I'll move the movie camera closer to the oscilloscope and you can see what it looks like. Powering down. All right. We've powered up the drive. Enabling the drive to run. Rotating the IRT motor resolver. You can see we have good high side, low side firing on U to V. Now, it's not perfect. That's because I'm rotating this motor resolver by hand. It's not at a constant speed. Okay, we'll move from U to V to U to W and see what that looks like. I've disabled the drive, powered the drive down, takes a little while for the bus capacitors to discharge. There we go, we've turned off. Now, moving from V to W. Okay, so this will be U to W. Powering up the drive. Enabling the drive to run. There we are. That looks good. See if we can spread that time out. Look at the pulse width modulation. There's our PWM. It's very good, high side, low side firing. All right, disabling the drive. Powering down. Now we're going to move from U to V. So we'll be looking at V to W. That will be the last of the test. I'll show you the hookups so you can test your Unitek. Oh, come on, get unclipped. So you can test your Unitek servo drive. Okay, are we on it? Okay. There's V to W. Powering up the drive. Enabling the drive to run. There we go. They all look the same. U to V, U to W, V to W. All look good. Spread that time out. Look at the PWM of V to W. Here we go. Okay, disabling the drive, powering down the drive. All right. Now, I'll put my hookups at the end of the video. I'll put those up at the end of the video, and you can test your Unitek servo drive. Good job, folks. You've resurrected another one from the dead. That one was a grizzly bear. All right. Have a good day, all. We'll see you in the next one. Good afternoon, all. Let's take a little bit of break from work and look at the hookups that we used for that Unitek servo drive. Now this is the front of the large Euro connector, and these little circles are the rows, and then I have the rows outlined with these squares right here, indicating that the columns are all connected together. Now this, on the far right of the connector, these 6 pins are U. Next door, these 6 pins are V, and then 6 pins for W. That's where we connect our motor. And in our case, we connected the Fluke oscilloscope. Now, here, these 6 pins are bus ground, minus bus. And these 6 pins are plus bus. That's red wire, blue wire that connected to the stake terminals on the power board. Then we had violet, brown, and black. Now, sometimes the colors are different, but usually this one is red, this one would be blue or black, and then sometimes the wires that connect to the stake terminals, these 3, U, V, and W, are all the same color, black. Here on the far left side is earth ground, frame ground, these 6 pins right here. Here are the resolver connections on the smaller Euro connector. The middle row is labeled B. The top row is labeled C, and the bottom row is labeled A. Now I didn't have the servo motor that mates to this drive, but I did have a resolver in the back of a knitting machine motor, an IRT motor. And so 12B is excitation plus. 14B is excitation minus. We connect that to the rotating transformer in that resolver. 4B is sine minus, 6B is sine plus. 8B is cosine minus, 10B is cosine plus. And I connected the sine and cosine to the sine and cosine connections inside that knitting machine motor's resolver feedback. Here are the connections that I used to make that servo drive run. Now down here is an input on 6C. It's called DC link. If you don't have that jumped to plus 15 volts DC on pins 32C, that drive will not run. You'll get a DC link alarm on that drive, and the DC link LED will be turned on. Here on 2A is limit plus, and on 2C is limit minus. Those are the limit switch inputs. They have to be made to plus 15 volts DC, or the drive won't run clockwise or counterclockwise. So those limits have to be closed. Here is the enable input on 30C. When you close 30C to plus 15 volts DC on 32C, that output, UV and W, is made. Here's the DC link circuit. Now, I couldn't figure out how to get the DC link LED to turn off, the DC link alarm LED. And so what I did was I mapped the circuit back from the LED itself through this inverter to pin 6C on the smaller Euro connector. Now, by pulling that up to plus 15 volts DC, we have a high here and a low, and then up here it goes off to let the drive processor know that we have this input here made. Now with a low here, that LED is turned off. Now if there's no input to 6C, we catch this low right here through the 10 kilo ohm resistor. So this input is pulled low and the output goes high, and the circuit is activated to let the drive know that this input is not pulled up to plus 15 volts. So here we have a low, a high, that LED turns on. Now I don't know where the rest of this circuit goes. I was just concerned that I could turn that DC link alarm LED off. And once I did that, I was able to run the drive. Let's look at our next page. Here are the limit plus and limit minus inputs. And the limit plus is on 2A, the limit minus is on 2C of the small Euro connector. So when we apply plus 15 volts to these two inputs right here, these input LEDs are turned on inside this optocoupler, part number PC815. Here's the last page we're going to look at. This is the enable input on pin 30C of the smaller Euro connector. Now there's a jumper right here. And what the jumper does is that the way it's set right now, we apply plus 15 volts DC to 30C. It comes through the jumper into the base of this NPN resistor from this voltage divider circuit right here. And that turns on the transistor, which in effect turns on the input of this LED inside the optocoupler. So a high here turns on that transistor, which in turn applies the cathode of the input LED to ground, and thus current flows through the input LED. Now if we set the jumper up here, we bypass that circuit, and you can apply a low to 30C, and it connects the cathode of that input LED of that optocoupler to ground. That's pretty ingenious right there. So you can have a high to enable a drive or a low to enable a drive. depending on where this jumper is set. All right, there we go. I think that's everything. If not, I can make another video. In fact, I should make another video on this drive on the power supply section, the switch mode power supply, because that goes bad too. I think I'll do that. We'll have a part 3 of this video, and I can show you all the stuff that goes wrong in that switch mode power supply. All right, all. Let's get out of here. We got things to do at the house. We got to do a little bit of house cleaning. One of the chores of life. Have a good day, all. We'll see you in the next one.